In this problem, let us see, find RMS value of individual harmonics and of total induced EMF per phase and line of a 50 Hz 3-phase star connected alternator with 10 number of poles. Basically, the detailed question you can download it from our website. Okay, so directly I have taken given data. Okay, see, 10 poles, slots per pole per phase is 2 and 4 conductors per slot and coil span of 150 degrees. Flux per pole is 120 milliwebers or 0.12 webers, and third harmonic flux is this. Okay, maybe some people may think that such a lengthy question may not come in exam. Yes, complete question will not come, but parts of the question can come. Okay, so let me in detail, let me do this problem. Okay, now he is asking per phase voltage and per line voltage. Okay, so per phase voltage, what is the equation? Induced voltage per phase equal to same transformer equation, √2 pi f pi average, number of series connected turns, and Kp Kd. Okay, now let us see Kp, pitch factor. Okay, in order to calculate pitch factor, short pitching angle should be given. Did they give you any information about short pitching angle? Yes, coil span of 150 degrees. What is coil span? For example, if I have two pole structure, for example, this is two pole structure. Okay, this is N pole, this is S pole. If I keep A here, if I keep A dash here, this is full pitch coil. Rather than keeping A dash here, if I keep A dash here, is going to be short pitch coil. Okay, now A to A dash 180 degrees. So coil span in this is, for example, A dash. So this is A, this is A dash, this is going to be coil span. Actually, I don't want to define what is coil span and all, because how can anybody ask define coil span? No, that is coil span. From here to here, coil span should be 180 degrees in a full pitched coil, but from here to here, it can be 150 degrees. So, if coil span from here to here is 150 degrees, means that it is short pitched by an angle of 30 degrees. So, from here to here, it is short pitched by an angle of 30 degrees. Such that coil span is 150, short pitched by 30 degrees. So Kp they have given or not? Yes. Okay. So let me calculate Kp for fundamental and Kp for triplet and harmonic component. So what is Kp? Kp is going to be cos epsilon by 2 for fundamental. How much is epsilon? 30 degrees. So cos 30 by 2 is going to be, okay. So cos 30 by 2 is going to be 0.966. Okay, now let me calculate Kp for third harmonic, because third harmonic induced voltage has to be calculated. Okay, so third harmonic component is going to be cos h epsilon by 2. H is going to be 3, so cos h3 into epsilon 30 by 3 is going to be cos 45 is going to be 0.707. Keep it aside. Now let us think of calculation of distribution factor. Now should I calculate distribution factor or not? Yes, because slots per pole per phase is 2. What does it mean? Out of complete slots per pole, per phase, we have 2 slots to distribute the winding. Okay, so see here, the moment we have slots per pole per phase of 2, so per pole per phase 2 slots are available for the distribution of the winding. So we have to calculate distribution factor. Now what is distribution factor? Distribution factor equal to sine q gamma by 2 by q sine gamma by 2. Now we may have to calculate q and gamma. What is Q? Slots per pole per phase. They have given 2. Now what about gamma? Let us calculate gamma. Okay. So what is gamma? Is nothing but slot angle. Okay. What is slot angle? Means for total slots, what are the angle? We have to calculate per divided by number of slots will give you slot angle. How many poles are there? 10 poles. Okay, so if I think of 10 poles, okay, 10 poles and each pole 180 degrees, so total electrical angle in the complete stator is going to be 10 multiplied by 180. 10 multiplied by 180 divided by how many slots are there? Slots per pole per phase is 2, so 2 multiplied by number of phases 3, 3 multiplied by number of poles 10. Okay, so what is the slot angle? Slot angle will come around, okay, some angle will come. Okay, now let us see how to calculate distribution factor. Now distribution factor fundamental equal to sine q gamma by 2 by q sine gamma by 2. Okay, so this is going to be 30 degrees actually. Okay, so what is sine, what is q? Slots per pole per phase, gamma 30 by 2 divided by what is q, 2 into sine 30 by 2, which will give you 0.966. Okay, now let me calculate distribution factor for third harmonic equal to sine q, angle should be h times gamma, so 3 into gamma by 2 divided by means q sine 3 gamma by 2. Okay, now you know q value 2, 3, gamma value 30 degrees divided by 2, if you calculate it will come down to 0.707. Okay, so pitch factors are ready, distribution factors are ready, we can calculate induced voltages. Now let me calculate induced voltages fundamental. Fundamental is going to be root 2 pi f pi number of series connected turns per phase into kp kd fundamental. Okay, of course this is going to be phase only, is going to be root 2 into pi into frequency given 50 into operating flux, they are given 0.12 into, focus dear all of you here, number of series connected turns. Okay, so how many number of slots are there? Calculate, all of you, we have to feel it. If you try to remember any equation, it may create a lot of problem in your exam because we'll be pressurized in the exam. Okay, see total number of slots in the stator, feel it, total number of slots in the rotor, okay, multiplied by conductors in each slot will give you total conductors, divided by 2 will give you total number of turns, divided by 3 will give you per phase. Though you may feel it simple, I will take old gate question, okay, then you will be confused, then you will get the better clarity. How many number of total slots are there? Slots per pole per phase is 2, multiplied by number of phases will give you 3, multiplied by number of poles will give you 10, total number of slots. Total number of slots multiplied by how many conductors per slot? Given 4. Okay, so total number of slots multiplied by conductors per slot will give you total number of conductors, divided by 2 will give you turns, divided by 3 will give you per phase. Okay, now kp1 kd1, we got kp1 kd1 of 0.966 into 0.966, which will give you, means per phase is going to be 994.8 volts. Fundamental. Now let me calculate triplet harmonic component per phase is going to be root 3 pi into, actually means in one of the very popular book he has done a mistake. Triplet harmonic component frequency should be 3 times fundamental. Okay, so if normal frequency is 150 Hz, triplet harmonic frequency will be 150 Hz. Actually there is we have to discuss a lot about space harmonic, time harmonic. By the end of induction you will get the better clarity actually about the harmonic. But now triplet harmonic component as it is time. Okay, triplet harmonic component should be 3 times fundamental only, so 3 into 50 root 3 pi f into operating flux of triplet harmonic into number of conductors or number of turns will be same between fundamental and this. into KP3 KD3. So this is going to be, I'm sorry, this is not root 3 dear, it is root 2 pi f, no? Okay, I'm sorry for it, but anyway, root 2 into pi into 3 into 50 into, in the question given, they said that 20% of third harmonic is there compared to fundamental. So 20% 0.2 of fundamental is 0.12 Webers. And number of series connected turns will be same, 2 into 3 into 10 into 4 into 1 by 2 into 1 by 3 into KP3 KD3. KP3 KD3 is going to be 0.707 into 0.707. Okay, so 0.707 you are going to get voltage of 319.7. Okay, so in phase fundamental also will be there, triplet harmonic also will be there. Okay, so what is the total per phase voltage? Is going to be fundamental square RMS, triplet harmonic square RMS under root. Okay, which will come down to 1722 point. I'm sorry, fundamental plus this is going to be 1045 volts. 1045 volts. Okay, now let us think of line voltage. Line voltage is going to be root 3 times phase voltage. No. Okay, basically in three-phase transformer already we analyzed that across lines there is no possibility of triplet harmonic component. Per phase triplet harmonic component can be there, but across lines triplet harmonic component cannot be there. Okay, so if you get any doubt, like try to revise, try to rewatch the video of harmonic component of three-phase transformer. Now root 3 into phase voltage, no, but triplet harmonic will not come, no, so is going to be E1 is going to be root 3 into fundamental, this is 994. Okay, which will come down to 1723 volts. Okay, now don't think of we solved big problem. It is not big problem. Okay, means now we are going to take Volgate questions, and we are going to add some other questions also. Then gradually you will get the clarity. Such a lengthy question you may not get in exam, but parts of this you can expect in your gate.